Hello everyone. In today's lecture, we'll be understanding NAIVE based classification. It is basically a probability algorithm which is used for machine learning algorithms. We will dive into the fundamental principles underlying the algorithm, explaining how it utilizes Bayes theorem and the naive assumption of feature independence to classify data. The presentation will cover various aspects including the different types of naive-based classification, example Gaussian, multinomial, Bernoulli's, etc. Their implementation in popular programming languages like Python and practical applications of their real-world scenarios. Finally, we will discuss the strengths and limitations of the naive-based classification, providing a balanced perspective on its use cases and potential pitfalls. Let's dive into the fundamentals of naive Bayes algorithms. Its fundamental algorithms involves Bayes theorem, which is basically we have studied in our 11th 12th class about the Bayes theorem, a fundamental concept in probability theory to calculate the probability of the class given to a set of features. Also, it includes conditional independence. Now, what is conditional independence? Naive Bayes assumes that features are independent of each other, meaning that the presence of one feature does not influence the presence of another. Presence of one feature will not affect the presence of another feature in the naive Bayes classification. Implementing NAIVE Bayes using Python. Mainly we are using Python because Python is relatively easy and everybody is familiar with Python. Later on we will see the code of NAIVE Bayes classification using Python in the VS Code IDE. Implementing NAIVE Bayes data preparation. First step obviously to prepare the data. The data should be processed to handle missing values, convert categorical features and scale numerical values. You can access the data preparation video in this playlist. Model training. Both Python and R offer libraries like NAIVE Bayes in R and sklearn in Python to train a NAIVE Bayes model. Basically, Python and R includes a library and we can import the libraries into our program for the model training purposes. Evaluation matrices like accuracy, precision, recall, and F1 score can be used to assess performance of the model in the NAIVE Bayes classification. Now let's see some real world applications before seeing the code snippet. First is spam filtering. NAIVE Bayes algorithms are used to spam filtering. That means to identify and filter spam emails based on frequency of words in the email contents. As you have seen in your day-to-day life that many emails are spam because everybody is exposed and every email ID is exposed out there. So there has been collected a various number of spam, and the NAIVE Bayes classification helps us to filter the spam. Sentiment analysis. Categorize customer reviews or social media posts into positive, negative, or neutral sentiments. NAIVE Bayes algorithm is very useful in recent time, and many apps like Instagram, Facebook, WhatsApp uses this to analyze the customer behavior, and based on it, like Amazon and Flipkart also uses it, based on which based on the sentiment of a customer they display which kind of product they need, and this in a way increase the sale of the company. Medical diagnosis. Very important feature of a NAIVE Bayes classification is it is used in a medical field, predict the likelihood of a disease based on patient symptom, medical history, and other factors. Based on the history of a patient, like in past he or she has suffered with any medical condition, NAIVE classification consider all these outcomes and predict and diagnose the medical condition of a patient. Now let's look at some code snippet in the VS Code IDE using Python for NAIVE Bayes. As you can see here, I have imported packages like pandas, sklearn, model selection, and sklearn.naive Bayes, import Gaussian NB. sklearn.matrices, accuracy score, confusion matrix, classification, etc. All these libraries are needed for NAIVE Bayes classification. As usual, we have data frame for classification where we have passed feature 1, 2 and target. Partition the data using test and test split. We have learned about these in previous videos as well. Now, first step is to build and train a NAIVE Bayes model using Gaussian NAIVE Bayes. NB is denoted NAIVE Bayes underscore model equals to Gaussian NB. It is a function. NB underscore model underscore NB underscore model dot fit xtrain ytrain. For prediction, we use ypred equals to NB underscore model dot predict, passing the parameter xtest. Now evaluate the model accuracy. Accuracy equals to accuracy score ytest ypred and printing the desired output as accuracy. Confusion matrix, as we have seen earlier, conf underscore matrix equals to confusion underscore matrix, passing the parameter ytest and ypred, printing the desired confusion matrix as confusion matrix. Classification report using precision, recall and F1 score, class underscore report equals to classification underscore report, ytest, ypred, printing the desired output as classification report. This involves the NAIVE Bayes classification code. With this, we have understood the NAIVE Bayes classification. Up until next video, we'll meet again. Thank you.